So exercises on limits of functions, algebraic approach. So let's take a case where the limit of f of x as x approaches a is simply equal to f of a. So that is just the value of the function when x equals a. Okay. Now, for the limit of f of x as x approaches a to be equal to f of a, so it must be something like this, no? So let's say this is my x-axis. And then I have my x equals a here. And then here we have x sub 1 to the left. And to the right, we have x sub 2. If the graph of f of x at x equals a is defined, so meaning there is a point here at x equals a, and there is an immediate left value, immediate left, and there is also an immediate right value, meaning immediate left point and immediate right point, no, at x from x equals a. So that is the graph is like this. Okay, so something like this. Yeah. So again, I am interested with the behavior here, and I can move from the graph, I mean on the graph, from this point x equals a, where x equals a, to its immediate right and to immediate left, however small the distance is. Clear, guys? However this distance, however small this distance is, I can move from x equals a to its immediate right and to its immediate left, meaning connected, no, to its immediate left and immediate right. If that is the case, so the value of the limit at x equals a is simply f of a. Okay? So further, it means that our f of a is defined. And also, f has an immediate left point and right point. From x equals, from a point where x equals a. Clear, guys? Did you get what this means? Actually, this can be explained precisely in continuity of a function. So when it comes to continuity, from x equals a, so it is continuous there, no? So if it is continuous at x equals a, meaning there is an immediate left and immediate right points, okay? So let us have the following examples. By the way, if that is the case, you can apply direct substitution. So apply direct substitution rule. So meaning you can just evaluate the function at x equals a. Clear, guys? Let's have number one. So evaluate the given limit. Limit of 4x plus 3 as x approaches 3. Now, this is a linear function, and we know that a linear function has a smooth graph, right? So there is no problem to the left of 3 and to the right of 3, no? So it is guaranteed that there is a left point, immediate point, and then there is also an immediate right point, no? From x equals 3. So we can apply direct substitution. So that is, we just evaluate this for x plus 3 when x is 3. So 4 times 3 plus 3. So that is equal to 15. Am I right, guys? Children?
Yes po, sir.
Yes.
What about when x is negative? What about number 2? Excuse me. Limit of 2x minus 3 quantity squared as x approaches negative 2. So again, this type of function has an immediate left and immediate right points at x equals what? Negative 2, no? So we can apply direct substitution rule. So 2 times negative 2, then minus 3 quantity squared. What is this equal to, guys? What's the value?
49 po.
49. So 49. So that's the limit. Number 3. Limit of 5 minus x cubed all over 3x plus 2 as x approaches negative 1. This function is undefined when x is what? When x is negative 2/3, no? Since we want only x that is close to negative 1, so it is guaranteed that there is an immediate left point and immediate right point from x equals negative 1, no? So we can apply direct substitution. So 5 minus negative 1 raised to 3 all over 3 times negative 1 plus 2. So the numerator is equal to 6, right? Over negative 1. Am I correct, guys? And that is equal to negative 6. Okay, children? Guys? So what about number 4? When you're dealing with radical, you have to be careful. So if the limit of the radicand, for instance, approaches 0 but through negative values, so you cannot apply direct substitution rule. So I think there is no problem in this case, no? Limit of the square root of 2x plus 1 as x approaches 4, because the limit of the radicand is positive, no? When x is getting closer and closer to 4. So we can apply direct substitution. Okay? So 4 times 2, no? Or 2 times 4. 2 times 4 plus 1. What's the value? Square root of 9, no? What is the square root of 9? So that is 3. So that's the limit. Okay? Number 5. Let's see if there is no problem around x equals 2 or near x equals 2 and together with x equals 2. So there is no problem, no? So guaranteed that there is an immediate left point and immediate right point from x equals 2 here, no? Okay? So we have, by direct substitution, 4 minus 2 squared quantity squared. Okay? All over square root of 2 minus 1. So that is equal to, is it 0, guys, the numerator? No? So 0 is squared, so that is 0 over 1. What's the value, guys? Is it 0, children? 0, no? Guys, still alive? Children?
Yes, po, sir.
Sir.
What about
Yes.
number 6? So when x gets closer and closer to 0, so what's the limit of this? So there is no problem when x is 0 and at the same time around x equals 0, no, for this function. Okay? Those that are just close to 0, no problem. It has a problem actually when x is negative 1, but we want only close to 0. So guaranteed that we can move from x equals 0 to its immediate left and immediate right. So 0 plus 1, then cube root of 0 plus 8, then 0 cubed plus 1, quantity to the fifth. So the denominator is 1. The numerator is 1 times 2, no? So that is 2. So finally, we have 2. So that's the limit. Get it, guys? Children?
Yes, sir.
Okay. So this time, we're going to have the case where the limit of f of x takes the indeterminate form 0 over 0. Okay? So again, we're going to take the case where the limit of f of x as x approaches a takes the indeterminate form 0 over 0. So normally, we encounter this when we have what? When we have quotient. No? Guys, am I right? So again, normally, if your f of x is a quotient, so we have, let's say, numerator in terms of x over the denominator, which is in terms of x. Yeah. Now, if the numerator and denominator's limits happen to be both equal to 0, then possible that the limit may exist, no? And how to get the limit, the possible limit, if that will be the case? You try to what? To factor the numerator, factor the denominator if you have polynomials in the numerator and denominator, okay? So if the numerator and denominator are polynomial functions, factor them, no? Factor them and cancel out the factor x minus a, okay, from n of x and d of x, okay? What about if the numerator and or denominator contains, let's say, radical, no? Especially square root. If the numerator and or denominator contain a radical or radicals, apply rationalization. Rationalization. Normally, if you have a square root, you multiply by the conjugate. Okay? So, pag square root, yung radical by conjugate, no? By conjugate. So, we know that a squared minus b squared is equal to what, guys? Guys, what is that equal to, guys? Children?
No, sir. A plus B, A minus B.
So, a plus b, a minus b. You're going to use this technique, right? What about if you have, let's say, involving cube root? So you apply what? We have a cubed minus b cubed. This is pag plus or minus, no? So it is a plus or minus b. If plus plus here, if minus minus here. The other factor is a trinomial, a squared. Pag plus minus here, pag minus plus here. Okay, guys? AB plus b squared. Am I right, guys? Okay, so that's the technique. Okay, so let's have the following examples. So evaluate the given limit. Number 1, limit of x squared minus 2x minus 3 all over x minus 3 as x approaches 3. What do you think here, guys? So let's check the limit of the denominator. Okay, so limit of x minus 3. So this happens to be what, guys? Children. Guys, this happens to be as x approaches 3, happens to be 0, right? Am I correct, guys? So the limit of the denominator is 0. If the limit of the denominator is 0, we cannot apply direct substitution. Guys, check also the limit of the numerator. So if the limit of the numerator will be 0 also, then it means we have indeterminate form, 0 over 0. Get it, guys? What about the limit of the numerator? So we can apply direct substitution here also, no? So that is 3 squared minus 2 times 2 minus 3. That is 9 minus, guys, 2 times, this is 2 times 3, no? I think I got a mistake here. 2 times 3 negative. So minus 2 times 3, then minus 3. So this is 0, no? So this means that this limit takes the indeterminate form 0 over 0. Okay, guys? Guys. So we try to what? To apply the technique of factoring, no? Let's simplify this rational function here in the limit, no? So limit as x approaches 3 of x squared minus 2x minus 3 all over x minus 3. So what's the factored form of the numerator, guys? Children, one of the factors is guaranteed x minus 3, no? Because the numerator becomes 0 when x is 3, no? So the other factor is x plus 1, no? All over x minus 3. Am I right, guys? So from which we can now cancel out x minus 3. We are allowed to cancel out x minus 3 because we do not want x equals 3, but we just want x closer to 3. Okay, so what we are doing is we are trying to find a function whose limit is the same with the limit of this original one, no? So this function x plus 1 and x squared minus 2x minus 3 all over x minus 3 have the same limits when x gets closer and closer to 3, but they are not same function, huh? They just have the same limits. What is nice is that in this new function that we have, that is x plus 1, a linear function, there is an obvious limit, okay? We can apply substitution technique, unlike in the original. Clear, guys? What is now the limit? We can apply direct substitution here, no? So 3 plus 1. So the limit, therefore, is equal to 4. Okay, children? Get it, children? Okay, let's have number 2. So limit as x approaches -2 of the numerator is 4x squared plus 5x minus 6. The denominator is 3x squared minus 4x minus 20. By the way, do not substitute and get equal 0 over 0. Ha? Do not do this. Ha? For instance, if you have limit of x squared minus 1 all over x minus 1 as x approaches 1, do not write this. Ha? 1 squared minus 1 all over 1 minus 1 equals 0 over 0. Ha? Guys, it's not correct. Many are doing this. No? This is not right. Okay? We cannot apply direct substitution and write like this. Okay, guys? Is that clear, children? Guys?
Yes po, sir.
Okay. So what you do, you can do it, just do it mentally. So instead of writing limit of the numerator, limit of the denominator, you try to find the limit first of the denominator, no, like this. So in just parang guide, no? What is happening to the denominator, guys? Is it getting 0 when x gets closer and closer to -2? What is the limit of the denominator? So apply direct substitution to that. 3 times 4 plus 8, no? Minus 20. So the limit of the denominator is going to be 0. What about the limit of the numerator? So it is going to be 0 also. The limit of the numerator is 0. The limit of the denominator is 0. So it means this limit has the form 0 over 0. Do not equate, ha? So 0 over 0 is just a form. It's not the value of the limit. So this is indeterminate. So we can now proceed. Apply factoring, no, to the numerator and denominator. Limit as x approaches -2. Okay, so let's have the numerator. What's the factored form of the numerator? Guaranteed there is x plus 2, no? So the other factor is 4x minus 3. Am I correct, guys? The denominator, one of the factors is x plus 2. Then the other factor is 3x minus 10. Am I right, guys? So from which we can now cancel this out so that we have a simplified limit, no? Okay. So this limit has an obvious limit this time compared with this original one. So we can apply direct substitution. 4 times -2 minus 3 all over 3 times -2 minus 10. Oh, what's the value, guys? Could you please give me the value, children? What is the numerator? -11. Denominator. Is it -16, guys? 11 over 16. Am I correct, children? Guys?
Yes, sir.
Yes po.
Yes
Okay.
po.
So number 3. For number 3, we have limit as x approaches one of this quotient x cubed plus 6x minus 7 all over 2x squared minus 5x plus 3. Okay? So what about this, guys? Okay, so let's do mentally the limit of the denominator and the limit of the numerator. For the limit of the denominator, applying substitution technique, 2 times 1 squared minus 5 times 1 plus 3. So the limit is equal to 0. What about the limit of the numerator? 1 plus 6 minus 7. Huh? It is also 0. So it means this limit takes the indeterminate form 0 over 0. If that is the case, we have to express sorry. We have to express the numerator and denominator in factored form, no? But the denominator, so what I mean is the numerator, no? But the numerator is not easy to factor, no? So we can apply synthetic division in factoring numerator. So let's have that. So 1 for the numerator. So we have x cubed plus 6x minus 7. So let's see. We have, what's the factored form? So by synthetic division, we have 1, 0 for the coefficient of x squared, 6 for the coefficient of x, then -7. No? The number that we are going to try here, 1. Because we know that x equals x minus 1 is a factor, no? So When bring down 1, multiply by 1, 1 times 1. So that is 1, add, multiply by 1, add, multiply by 1, then add. So this means that the factored form of x cubed plus 6x minus 7 is x minus 1, x squared plus x plus 7, right? Okay, guys? So we can now proceed. So this means that the limit is the same as limit of x minus 1, x squared plus x plus 7 all over, what is the factored form of the denominator? So one of the factors is x minus 1, no? So the other factor is 2x minus 3. Am I correct, guys? So as x approaches 1. So we can now cancel this out. Okay, children? So this is equal to the limit as x approaches 1 of x squared plus x plus 7. So this new function has an obvious limit when x approaches what? 1, no? Compared with the original one. So we can apply direct substitution here. 1 squared plus 1 plus 7 all over 2 times 1 minus 3. So this is equal to 9 over negative 1 or simply negative 9. Get it, guys? Children? Okay, what about number 4? Limit as x approaches 2 of 4 minus square root of 5x plus 6 all over x minus 2. So this contains radical, okay? When you have a radical, you have to be careful, no? You have to check the limit of the radicand. The limit of the radicand as x approaches a specific number must be what? Must be greater than 0, or if it's getting to be 0, through positive values. Otherwise, you cannot apply direct substitution to that square root. Okay, children? So when x gets closer to 2, 5x plus 6, I don't think it will have a problem, no? It's going to be positive, the limit, no? So we can proceed. What's the limit of the denominator, guys? 0, okay? What's the limit of the numerator? 5 times 2 is 10, plus 6, 16. Square root 4, 4 minus 4, 0. So it means it has the indeterminate form 0 over 0. The technique, as what we had in our discussion, we're going to what? Multiply this by the conjugate, no? Both the numerator and denominator. Clear, guys? So that's the technique. We rationalize the numerator so that we will able to get rid of later the factor making the numerator and denominator 0. So 4 minus the square root of 5x plus 6. Okay? So we have times. So denominator is x minus 2, no? What is our multiplier, children? Conjugate 4 plus the square root of 5x plus 6, right? We multiply also the denominator. so that there is no change in the value, no? So this is equal to the limit as x approaches 2 of, what's the product, guys? In the denominator, we have x minus 2, 4 plus square root of 5x plus 6. What about in the numerator? A minus b, a plus b. What's the product? Square the first minus square of the second. So that is 5x plus 6, no? You enclose half because this is preceded by negative. Okay? Guys, am I correct, children? Guys? Any question, guys? What is the numerator, guys? So this is 10 minus 5x, no? Am I right? If you factor out 5, we get 5 times x minus 2. Or am I correct, children? Or negative? Factor out negative. Is this the same with the numerator, guys? Guys, the numerator is 10 minus 5x, right? If I factor out negative 5, I get what? X minus 2, no? What about the denominator? We just copy, no? So getting x minus 2, 4 plus square root of 5x plus 6. Okay, guys? As x approaches 2. We can now cancel this out, no? Guys? So getting limit as x approaches 2 of negative 5 all over 4 plus square root of 5x plus 6. I think the denominator does not have any problem anymore. Okay, we can apply direct substitution here. So the limit is for the denominator 4 plus square root of 5 times 4. 5 times 2 plus 6. Numerator is negative 5. This is equal to negative 5 over 4 plus 4, right? So that is 8. So finally, we get what, guys? So negative 5 over 8. Okay, children? Guys,